What is up? Hello, hello, welcome, welcome. We have some installs to do today. Some customer send-ins. My whole workspace is in complete disarray. Excuse me while I do a little cleanup. Alrighty, today we got a couple of PS2s. We're going to be installing iFlash kits in. Let's see, the first one looks like the first one. Let me look some things up here. One, two. Okay, yeah. The first order we're working on today is order number 4102. And I believe, let's see, get that up there. Order number 4102. Now I believe this is just a iFlash install, nothing else, no retro gem or anything like that. So let me pop open the customer's package real quick and I will take a quick inventory of everything. Okay, we got an iFlash Solo. And we have a PS2 Slim SCPH 70012. Listen, Alteracious, look. Let's not be children here, okay? We're all adults here. Alright, we're gonna do a quick test run here on the console just to make sure everything's working properly before we open anything up. Alright, let's see here. Go ahead and jump over to game capture real quick. First thing I'm going to try to run a free DVD boot disk just to see if it'll boot it. That'll tell us if the laser is working or not. Yep. Looks like we're good. Okay, so this PS2 seems to be in perfect working order. Brian, I don't think it is your order yet. I think your order is next. Alright, let's see here. This PS2 has never been opened before. So we're going to have to cut the seal. These gloves, these are just nitrile gloves. You got to get the ones made in Malaysia. That's your problem. I don't even know if there's a brand on these. I have a bunch of boxes of these from my former employer. During COVID, we stocked up on tons of these extra gloves and stuff, and then I was the only person who used the extra large gloves in my office, and then that company went out of business, and when it did, they just gave all that stuff. They just gave all the boxes to me, so I'm pretty much stocked up on gloves. My camera really seems to be struggling to keep focus. Let's see what's going on here. Why are we having so much trouble with focus? That looks okay. Alright, we'll continue. Hopefully that focus issue is solved. I changed the focus mode. Maybe it'll settle down a little bit. Actually, I'm going to switch over to my electric screwdriver for this, because these screws are kind of sticky on this console. All right, let's take a look inside here. Come on. There we go. Alrighty, let's go ahead and pull out the bottom screws first. Alrighty, let's switch over to the microscope and we'll get started with the soldering. My whole workbench is such a mess right now. I've been working non-stop for the past couple of weeks on the scalable video switch prototype, dialing in, well, at least for the past week since I've had the actual hardware, but even before that I was doing some perf board prototyping, and it has consumed my life. You don't realize how much work it takes to develop a product that's kind of complex like that. Until you start getting into it, you think, oh man, this will be simple. This will be easy. But then things start breaking. And then you realize you gotta redesign. And then you realize you gotta redesign again, and you gotta redesign again. Usually, firmware development is where the biggest problems arise because you typically go into it with an idea about how the firmware is going to work, and then when you actually start programming, things start falling apart, and then you have to rethink your approach. Usually my initial plan and the final product are very different from one another. Alright, so this is the new Flex. Oh. This is the new Flex design, and this little cutout did not... There we go. didn't cut out all the way from the factory. So this is the newest Flex revision. It's a slight change, but I've reworked some of the geometry again. And as you can see, the wire routing is a little bit different compared to the older Flex if you've seen my other installations. This space for this little resistor here is cut out more cleanly than it was before, and I've rerouted some of the wires around this resistor package instead of around the other side of the Flex here. So that makes it a little bit more efficient. There are also some changes to the other side of the board, but we'll go over those once I get that soldered in. Oh, thank you, Alteracious. I appreciate that. Firmware design is the thing that I tend to have the most trouble with. Because it's just like designing firmware is pretty simple. Like programming is pretty simple. I mean, you kind of just, it's kind of like what you see is what you get. It's very like, the logic of writing a program is a very straightforward thing, but when concept meets reality, a lot of times things don't work the way you think they will when you're just imagining it in your head. At least that's my experience, but I might be an idiot, so there's that possibility. I would never discount that possibility. Hey, we're done up here. Okay, so down here, the biggest change that I made is I once again adjusted the positioning of these pads for these 3 resistors to get them as close as possible to touching the resistors without having to bridge much distance at all. So that's the biggest change. And I do think that it makes this even easier to install. There used to be a wider gap there. Okay, those all look good. All right. So the power board has been updated as well. You won't be able to tell any difference because it's such a subtle difference that it's not visible to the naked eye. But the SD card slot has been bumped over to the right by 0.25 millimeters. And in doing that, the slot aligns more reliably with the vent hole on the PS2 shell. So it makes it easier to install this aligned correctly. Okay, let's pop this into the shell and check the alignment. Oh, for flux, what I typically use, although I do have a couple of different fluxes, but what you usually see me use for these installs is MG Chemicals 836 LFNC. This stuff is, how do I put this? It's not amazing as flux. Like, it evaporates really quickly. You have to apply a lot of it throughout your soldering because it spins its flux, properties pretty quickly. But it is a lot easier to clean up and deal with than any of the other fluxes that I've used. So for most applications, I like to use this flux. There are special circumstances where I will use this Amtech flux. This stuff is really amazing flux, but it is very difficult to clean. So I only use it if I'm planning on ultrasonic cleaning the board afterwards, because that's really the only way you can get it clean. But that flux is amazing, though, that Amtech flux. Okay, let's do a little test of the fitment. Yep. That's good. So we'll go ahead and solder in the power. All right. Before we remove the SD card slot from the customer's iFlash, we are going to test and make sure that it's working. And the way to do that is to solder a wire to this pad on the flex cable that's labeled 3.3 volts, and then a wire to the power board for the pad that's labeled 3.3 volts. And then we can install the iFlash without actually removing the SD card slot. Yeah. Okay, and we'll grab an SD card. Okay, we don't have the heat sink on, so we're not going to do this for very long, but we are going to boot this up and see if it's recognizing the SD card. Always a good idea to do this before you proceed any further, because the next step is a bit destructive. So if you end up having problems after that step, it's kind of hard to know for sure where the mistake was or where the issue was if you don't test here at this point. So I'm going to boot into the HDD tester utility. Okay, so it did detect the hard drive. The reason that the video looks so blurry right now is because I'm using a composite cable. I normally would use a RGB or component cable, but I ended up pulling my component cable and putting it back in my entertainment center. So I don't have much. I don't have a good quality cable set up here right now for PlayStation. Okay. So we're going to go ahead and shut it off there. It did successfully do a transfer. So we know that not only is it detected, but the SD card is communicating correctly. So that's what we want to find out. Go ahead and pull the plug for now. And we'll remove this power wire because you don't need it after the test. I'm going to go ahead and get my hot plate plugged in and we'll let it heat up. Then while it's heating up, we'll go ahead and install the SD card extender flex cable. Oh, Zarklord, you installed the Wii HDMI mod? Awesome. That's an old classic. I always loved that mod. It's one of my favorites that I've worked on. It just never really got the kind of traction I was hoping for, though. Not a lot of people have bought them. Kind of a bummer, because I feel like it's a really nice mod if you want an HDMI on a Wii. Okay, looks like we're back. I don't know what happened there. It seems like the stream... OBS said the stream lost connection. Might have had a ISP blip there. Alright, we're gonna hop back over to the microscope and get our SD card flex installed. Okay, it looks like our hot plate is ready. Done. All right, we'll go ahead and get this out of here. All right, here's our 3D printed bracket. This is a slightly redesigned bracket. I've adjusted the positioning a little bit. And there's a little peg you have to snap off of there that I forgot to. This is actually the first install I'm trying with the new adjusted bracket. So we'll see how it goes. Seems like maybe there's a slight issue with the way that the bracket lines up. Uh-huh. I see what the issue is. Okay. So I am gonna have to go in and rework this new model a little bit. But it's not too bad. But I'll be able to use this one. Just have to clip another little piece off here. Okay, so it should go like it's supposed to now. Maybe. Yes, there it goes. Okay. Yep, so I'm just gonna have to change the geometry of the design just a little bit, because it turns out my model of the iFlash board, I guess, doesn't have exactly the same radius angle as the real iFlash board, so that wasn't noticeable with the old design because it didn't come close to that particular corner, but it does now with the new design, so minor adjustment needed. Yeah. Definitely needs a little bit more fine-tuning. So what I did is I adjusted the position of the iFlash board to take a little bit of strain off of the main flex cable, because in the old design, the way that the iFlash board was positioned, there was a little bit of strain on this flex cable. But I may have moved it a little too far, because now there's not much, but there's a little bit of strain on the SD card extender flex. So I think I need to go back and adjust it again, but try to kind of get somewhere in the middle to where that neither flex cable has much strain on it. But hey, you know, it's a work in progress. This is an improvement over the old design, because the old design really put a lot of stress on the main iFlash flex cable, so this is definitely better than that. All right, let's do a proper test now. We'll get into OPL and get a game running. I'm gonna go ahead and put the bottom shell on. Oh, sorry. Forgot to get you guys on the game capture. God, that composite video looks so bad. That's amazing. Amazing that that's what we had to deal with back in the day. All right, let's go ahead and fire up Metal Gear Solid 3. And I'll just leave that running for a while. And we'll test, we'll get another console up and running here after this.
After the end of World War II, the world was
All right.
east and west.
We'll let that run for a little while, and while that's happening, I'm going to go ahead and get started on the next console in our list. Let's see, the order number is 4266. There we go. 4266. We have iFlash. We have a cap kit from Console 5, because we're going to be recapping this PS2 as well. And we have a PS2 Slim. 70,012. My favorite. The 12 really is the best one for this mod because it's easy to work with. And you might wonder what makes it easy to work with. Well, let me tell you. The 70,001 typically has the GH32 motherboard, and the GH32 motherboard has the separate emotion engine and graphics synthesizer chips. And if you're doing any kind of like, well, for the iFlash, it doesn't really matter. But if you're doing like a retro gym or anything like that, oh man, the 70,001s, I hate them. I hate the combined EEGS, or the separate EEGS. It's just super annoying the way that everything is routed on that one. Also, in my experience, they produce more heat. Now, the wattage rating is the same for both models, but anecdotally, my experience is that they produce more heat. We're going to test this real quick. Get my second power supply here. I'm gonna borrow the video cable real quick from the other PS2. I don't think it likes the free DVD boot. Let's try a real PS2 game. Okay, it does boot real PS2 games. So we're good there. All right. Get the AV cable plugged back into the other PS2 so I can resume testing. And we'll jump back over. Okay, so we're going to be opening this one up. This one also has never been opened before. So we need to slice the warranty seal. Okay. So the first order of business on this PS2 is going to be doing the recap. I don't want to have to be dealing with the iFlash Flex while I'm recapping the board, so... All right. Let me hop over to Console 5 just to have a look at their info about the PS2. Alrighty, this is a GH35. Huh. Well, they don't have a listing for the GH35. They have the GH32 motherboard, but not the 35. So what we're gonna have to do is we're just gonna have to look over and check the values on all the caps and just replace them as we go. Now, presumably, the caps are going to have it's probably going to be a similar lineup of caps between the GH32 motherboard and the GH35 that we have here, but there could be some differences because these two motherboards, while similar, do have a couple of areas where they're very different. So let's zoom in here and we'll take some stock of what caps we have available to replace. So around the power and video section, we have this big guy, 470 UF, which should be replaced by this guy. That's a 470 as well. And then we've got four 220s. And that'll be replaced by this group of 4 220 or 220 UF. I don't know what I'm thinking ohms. I got resistors on the brain right now. Okay, and then we got these little guys, which appear to be, well, there's one here, one here. Those are 10 UF, and we have some 10 UFs here, so those will replace those. And then these guys, 3.3 UF. Let's see, which ones are those? Well, I'm looking at the kit and I'm not seeing any. So it looks like maybe this motherboard has those, but the other variants do not. Unless it's supposed to be these tantalums. Let's see, what are these? Hold on, let me look under the microscope. Okay, it might be these tantalum capacitors. Let me go look them up. Okay, yeah, based on the code on the top of the capacitors, these are 3.3 UF. So I guess these tantalums are meant to replace these two electrolytic 3.3 UF capacitors. All right, well, let's go ahead and start replacing these that we know for sure, and then we'll keep looking for other capacitors that we have in the kit here. And if we can't replace every capacitor, then, you know, it is what it is. The kit apparently was not specifically designed for this variant of the motherboard, but it seems like the capacitors are the same so far. We'll get our hot tweezers in here. Oh. All right. Get a little bit of fresh solder under here. Alrighty. One down. I don't know how many to go. Okay, let's go ahead and get these 220s. Yeah, Brian, on the Console 5 wiki, it does not list any capacitor locations for the GH35 motherboards. That's where the confusion is. I was looking at the wiki to see which what the component numbers would be, and it's not listed there. Probably just an oversight on Console 5's part. They may have just never updated the page. Okay, this should be the last of those 220 or UF capacitors. Let's see, that's not going to be a good angle. Let's try from this side. Let's see here. Kind of tricky to get the right angle in here. There we go. Okay. Then these two 3.3 UF capacitors are the ones that need to be replaced with the polymer caps. Or the tantalums, if you will. Well, that one blew up. Too much heat. See if we can not blow this one up. Nope. Come on. That is tough. That ground plane is extreme. I peeled up a little bit of it. That's crazy. Let me take a look at it under the microscope. See what the damage is. Oh, it's not a ground plane. It actually is a... does actually go to a pad. Goes to a via. There it is. Should be recoverable. Okay, the pad is not broken. So I should be able to solder onto it just fine. And I'll reinforce it with a little bit of resin once I'm done. Alrighty. Now, tantalum capacitors are kind of weird. The polarity, unlike every other capacitor type, the polarity band on a tantalum capacitor tells you where the positive side is, not the negative side. Any other capacitor, it would be showing you the negative side, but tantalums, it's the positive, so you got to look out for that. Got a good connection there where that damage trace is, so we're good. All right, we got a couple of these 10 UF capacitors that are going to replace these two here. Okay, I should be able to get to these at an angle that won't cause them to explode. The other ones exploded because I couldn't get a good angle where I wasn't heating the sides of the capacitor up so much, and these are such tiny capacitors that they just popped from the heat. All right, that does it for this section up here. Okay, so there should be let's see, what are these? So that's 100. They're all 100. Some of them are 4 volt, some of them are 16 volt. Let's see, what do we got? So that's going to be this one. Let's see. Okay, that all makes sense. So yeah, these are the ones for the bottom. Wow, this one really doesn't want to come up. I think this one goes directly into the ground plane back here, and it has probably no thermal relief at all. Yeah. Yep, that's exactly what it is. There's 0 thermal relief there. Oh, yeah. My precision tip is not even going to be able to heat this up enough. Actually, that is so extreme that what I'm going to do is completely clean the pad off. Clean the pad off completely. And we'll apply the capacitor from the positive side. We should be able to actually heat that side up. reasonably easily. And then we'll come back in and actually solder the other side. These capacitors down here are brutal. They just have these huge direct ground plane connections. Okay, one more down here in this corner, and then we can move on to the center group of capacitors. Brian, to be honest with you, probably the capacitors probably don't need to be replaced on this console. I'm not aware of any issues, prominent issues with PS2s and capacitors, but you know, it doesn't hurt to replace them, I suppose, but I don't think it's strictly necessary. Let's see, what's the best angle to get this thing at? Crazy. It is crazy how intense some of these ground planes are. It's one of the most brutal recaps I've had to do. It's not an easy board to work with. Bridge is killing me. Oh. I think it's cleared now. Nope. Well, that bridge is actually fine. Now I'm looking at it under the microscope. They're both connected to the ground, to the same exact ground point, so the bridge being there doesn't really matter. It just annoys me. But I managed to clear it. Okay, last capacitor. There we go. Okay, let's do a quick once over, double check polarity. Against my motherboard photo. Okay, that's right. That's right. That's right. That's right. That's right. That's right. Those two are definitely right. That one's right. Okay, let's see. All right, so down here we got this one is right. This one's right. This one's right. This one's right. And this one is right. Okay, and then let's see, the last location. That one's right. That one's right. That one's right. And that one's right. So that's it. The recap is complete. For the broken pad, I'm not using resin on the pad. I'm going to use some resin to just hold the capacitor in place. So what I'm going to use is some UV cure resin. It's just activated by UV light. So let's see here. I'm just going to clean up this area around these capacitors. And basically the idea is I'm just going to put a dot of resin between the two capacitors to kind of anchor them together. Like so. Now, if you ever need to remove this, you can by just soaking it in isopropyl alcohol. That will cause the resin to release, and you can just pick the resin out of there. But we just cure this with some UV light. And now that resin is hard, so nothing can cause that capacitor to get knocked off or anything like that. All right, let's do a quick test here. We're going to fire this PS2 back up and just make sure that everything's still working as usual. Our other PS2 is still going strong here with Metal Gear Solid 3. Unplug that for a minute so we can just do a quick test fire of this PS2. Yep, everything looks normal. Cool. All right, now we'll go ahead and start doing the iFlash install on this PS2. Got the iFlash Flex. Oh yeah, you know, I felt like the previous generation of the Flex, which is probably what you have, because I've only been sending out the newest new one for like a couple of days now. But I really do feel like that adding those little hooks definitely helps a lot. And the new Flex is even better because the hooks are dialed in just a little bit more, so to where they're right where they need to be. Okay, let's hop over to the microscope. Let's get started on the iFlash Flex. Okay, so you can see if you have the older version of the Flex, the resistor furthest to the right, the pad was slightly further away from that one than it is from the rest of these, and that was just an error in the dimension transfer from the reference photos of the motherboard to my PCB design software. But I fixed that on this revision, so now the pads are even closer and easier to use than they were before. All right, we're gonna do a little test fit of the power board. And then we'll do our test run with the iFlash before we remove the SD card slot. Yep, that's good. All right, let's do a little test run here. All right, let's see if we get the SD card detected in the HDD test application. Yep, there's an SD card. Let's do a quick read test. Okay, yep. Looks good. All right, we'll go ahead and bring in the hot plate and get ready to Okay, test PS2 still going from the previous order. So we're gonna go ahead and get the hot plate back out here. Okay, we'll go ahead and install the SD card extender while we're waiting for that to heat up. Okay, hot plate should be ready to go. All right. Let's get our frame. Let's see. Oh, wrong way. Okay. All right, so let's give this a test. There we go. Wasn't snapped in all the way. Felt like it was super wobbly on the desk. It shouldn't be super wobbly. Okay. Let's give this a test run here. Okay. That's looking good. Ooh, that's weird. Hold on, let's give that another try. Okay, it's not detecting the SD card. Let's see. Let's go into HDD test. We'll find out why not. Ah, okay. So it's detecting the iFlash, but it's not reading the correct values from the card. Let me look at something here. Sometimes that happens if the flex cable is not seated all the way in the connector of the iFlash. And it's possible that it got knocked loose whenever I was working on it. It did stop reading right whenever I snapped it down into the case, so it might have just, the flex might have just been slightly loose, and then popping it down in the case sealed the deal. So we'll go ahead and give this a try again, and go ahead and pop it down into the case first. Well, seems that's not what it was. Yeah, it's still detecting the incorrect capacity. Okay, so here's what we do in this case. First thing we're going to do is we're going to check the SD card flex and make sure that we're getting good connection on all of the pins of the SD card flex. Not getting a connection here. Yeah, we have a bad connection on the SD card flex. Let's see. Okay, now we do have a good connection. Let's try this again. Oh, we're still getting the wrong size. Getting the wrong capacity reading. I'm gonna try a different SD card. That SD card should be good because that's one of my main test cards, but I want to give another card a try because of you know, just due diligence. And if there's still a problem after this, then that probably means there's something wrong with the soldering on the flex. So I'll just have to go through all the flex connections again. So I detected the correct capacity there. Interesting. Did this SD card die on me? Let's pop this SD card into the other console and see if it's detected correctly by it, because that console's been running continuously for like an hour and a half now with no issues, so let's just give it a shot, see what it says. Nope, this one's not detecting that SD card either. I think that SD card died on me. I think this SD card just gave up on me on stream. That's crazy. Well, I'll take it to the computer and try to see if I can reformat it and recover it at all, but all right, well, let's try powering this up with the other SD card that we've been using for most of our testing, because it did detect that one properly. Yep, detected this one just fine. Let's load up Metal Gear Solid 3 and see if we have any issues launching it this time. Yeah, I think this card just corrupted on me. That's crazy. I have had this card for a long time. This has been a test card that I've used for a couple of years now for various different things.
After the end of World War II, the world was split into two, East and West. This marked the beginning of the era called the Cold War.
All right, everything looks good here. I'm gonna go ahead and get the lid put onto this one as well. Can't believe I lost an SD card today. It's okay though, I've got spares.
Flying over Pakistan, altitude 30,000 feet.
Approaching Soviet airspace.
20 minutes to drop off.
Commencing internal depressurization. Equipment check. Arm main parachute.
All right. You ready to go?
Drop zone still showing a high pressure mass. Cav okay.
Good. We've got high visibility.
Come on, cooperate. There we go.
Oxygen hose to interior connector.
Oh,
Put on your mask.
forgot to do the last 2 screws into the drive sled.
Does this panty waste know what he's doing?
Approaching release point.
10 minutes to drop off.
Hey, are you deaf?
He said put out the cigar and put on your mask.
All right. Well, that's ready to go now too. Yeah, Brian, what I'm guessing is that bad connection that we had on the Flex, probably what it was. So, some of these, this board, this power board that I installed in here, this is part of this group of power boards that I've had here. This power board is a different version than the ones that I actually ship out. And in manufacturing, a little bit of corrosion developed on the surface of the pads, and so I have to like add extra solder and really get a lot of flux in there to clear the corrosion off of these pads. The reason I don't ship these out is because I don't want customers to deal with that. But for installs, it's not a problem because I can fix the issue here. But that's what I used in this, and it's possible that I didn't have a completely solid solder connection, and so just the force of putting the console into the shell might have caused that connection that was barely hanging on to break free completely. And that could have corrupted the card when it happened, because it might have been in the middle of a read or write operation, because I don't know. The way that OPL works is that it emulates the optical drive inside of the IOP controller. And so it's possible that there might be write operations happening while it's reading the card. I don't know. And if something like that happened and that connection broke in the middle of it, it could have just fried the card right then and there. So that's a possible explanation. I am going to take this to the computer and try to see if I can recover it, but I have a feeling it's probably dead. That SD card was originally for my Steam Deck whenever I first got my Steam Deck. I've upgraded to a larger card now, but this was a good test card for this project here. So if it's dead, it's sad to see it go, but I have gotten a lot of use out of it in various different places, so... But anyways, everything's looking good. I'm going to let this run for about probably a half hour, and we'll see how it goes. But if there are any issues, I'll address it then. But yeah, that pretty much covers it for today. I had those 2 installs to do, and that's pretty much all I needed to do. Brian, I'm gonna send you an email here in a little bit, and we'll work out the stuff on the recap that we did here. But unless anybody has any other questions, I think we're gonna call it there. Oh, if you want to see something cool that I've been working on, let me switch over to the main camera. This is the scalable video switch prototype. Ooh, look at that. How cool. So right now, this is just, all I have right now is SCART modules, but I have component and composite and S-video modules being manufactured right now, prototypes. So I'll have something to show for that soon. But basically, each module, you can add as many modules as you want. Up to a limit. There's like a... I'm working on the programming right now. I think the upper limit is going to be 50 modules, which I can't imagine anybody even getting close to, but that should be the theoretical limit for some. There are some constraints in the programming that make it to where doing more than 50 is not really feasible. But you can add in as many inputs as you want. You can also add as many outputs as you want. And if you look here on the front, you have all these switches. Each module has a switch for the low pass filter, so you can turn the low pass filter on or off based on whether you need that for your console or not. And then you have a push button up here where you can manually control the inputs, but this actually has auto input detection, so when you turn on a console, it'll auto switch to the correct input. And then on the back, we have a USB-C port, and we have this 3.5mm jack, which actually is not for headphones or anything. It is actually for one of these little IR blasters. So you plug this in here, and then you route this to wherever you need to send some IR, infrared remote signals. So if you have like a RetroTink 4K or 5X, you can route this to the RetroTink and it will control it using infrared signals, just like if you were pushing buttons on the remote. So you can save profiles, you can save remote profiles to each input, and then whenever it switches to that input, it'll automatically send the remote signal to your scaler. So you have the correct profile and everything set up automatically. So that's it. Still deep in development right now. It's a I'm writing software right now, and it's a huge undertaking. It's way more complicated than I thought. Yeah, the main thing that frustrates me, has always frustrated me about the RetroTink products, is the fact that they don't auto switch to the active input. And I'm sure Mike has a reason why he does it that way, but to me, that would be a really nice feature. So having the remote codes built into it where you can switch, you can send a remote signal automatically when you switch, that takes care of that problem, because the RetroTink, you can just send it a signal to tell it to change to the correct profile with the correct input anytime that console turns on, and then you're good to go. It's like it automates the whole process. So I'm excited to get the next round of prototypes. I'm hoping that will be early next week, because then I will be able to show some cool features, and I'll be able to get the software nailed down more than it is right now. Right now it's kind of like I'm in a kind of a weird place where I can work on the software, but this hardware is not capable of doing some of the things that I need to do. So I can't really test some parts of the software because I'm limited by the original prototype hardware. It doesn't have the right components to be able to do some of the things I want to do. So can't wait to get the new prototypes, because that way I can do the more advanced programming and actually test and debug while I'm working. So alrighty, well, I'm gonna call it there. I'm gonna leave this console running for a little while, let it play through some Metal Gear Solid 3, make sure there's no other issues, and then I'll be packing this one up and shipping it out to you. And then the first console I worked on tonight, that one's good to go, so I'm gonna go ahead and pack that up and ship it out. But we'll go ahead and call it there for the night. Thanks for showing up. I appreciate everybody who came out to watch, and hopefully I'll see you again soon.